Okay, so you guys have, you've done a little intro work. You've looked at the men that have done some work with the atom. We'll spend some more time on that later, but I want to go through some of the things that you can find on your periodic table today that we're going to start using. But first, let's look at the different models that you guys should be familiar with. Anybody remember the first model from the handout? What it was called? It's a weird one. No? Remember this? Historically, this is the first one.
Oh, the plum pudding.
Plum pudding model. I have to be honest, I've never seen plum pudding. However, this is the way it's described when you use most things. It's called a plum pudding model. So it's like pudding, think of it like this, with raisins. So this is where the pudding is like the neutrons and protons. And then the raisins are supposed to be the electrons floating around. Now, it didn't take very long for them to figure out that is not what the atom is like. Well, I guess it took a while, but clearly, from what we know now, that's just not correct. Anybody remember the second one? It makes a little more sense. Bad weekend, huh?
Yeah.
Second one was called the solar system model. We're getting a little closer, and it's the one most people kind of still think about when they think about atoms, where the sun equals the protons and neutrons. Whoops. And the planets, oh my gosh, equal the electrons moving around the sun. So it was based upon the solar system. So when you look at that, or when you think about that, think about, it's kind of like the ones you see in a book a lot of times. If you saw them carrying in models for physical science when they made their little atoms, they were set up like the solar system. Not exactly the correct way, but it's a good model. If I see a solar system model, it looks like this. And it's probably the way most of you guys would draw it. In here I'd have my little neutrons, and with that little zero beside it is a neutron, because a neutron has no charge. Plus I'd see my proton in here, or protons, however many there are, and then I'd see a ring out here, and it'd have my electron. And if I have more, I'd see another ring. Y'all have seen those in books. You probably drew them in junior high.
Yeah.
So that's sort of a traditional view. It's an old view. Now we have something called the electron cloud model. And that is where there's a nucleus, and it houses it houses the protons and the neutrons. And then outside of the nucleus, we have something called the electron cloud. And this is where I'm going to find the electrons. And they follow a path based on their energy level. And that's all we're going to say right now because you don't know much about that. So take a minute and pull out your periodic table when you're done writing that. So 3 models, you kind of should be able to trace the history. Tell me what's the most recent one. Tell me what's the oldest one. Tell me how it's changed. And then let's look at your periodic table. And if you look at your periodic table, everybody see the numbers running across the top? Like it goes 1 through 18?
Yes.
Yeah. Those are called group numbers, and we'll refer to them a lot in the future. So you really have to like pay attention and learn how to use your periodic table. There's like when you first look at this, it just looks like a lot of numbers and a lot of numbers, a few letters. Can't really make a lot of sense of it until you start figuring out what they represent. So let's write down this number, or let's write down lithium, and then let's look at some things that have to do with lithium. If I look at lithium, does everybody see that number 3? Yeah, can you find that? Okay, so lithium, number 3 is its atomic number. Now, does anybody remember from your definitions what atomic number tells us? How it's defined? Anybody want to take a guess? People, come on! Kirsten.
I think it's ordered by like the number of like atoms in it.
Okay, it's the number of something. This is 1 atom, so it's not the number of atoms. But you're on to something. Josh?
Is it protons?
It is. So this tells us the number of protons in the atom. From now on, or most of the time, you'll see protons like that. A P with a plus beside it. So we don't have to write out the whole word. So if I tell you to find, let's pick cobalt, CO. Find cobalt and tell me how many protons it has. So let everybody look, find it. It's pretty easy to find. When you have found it, raise your hand. Emma, how many protons does it have? 27. Now, can you guys tell me anything about the elements on the periodic table in terms of charge? Do you know anything about that? Are the atoms on the periodic table electrically charged or are they neutral? Do you know that? In the way they're represented, did you ever learn that before? Okay, so we should write that down then. All atoms as they are, I'm going to say on the PT for periodic table, all atoms as they are on the periodic table have no charge. They're called a neutral atom. So nothing on there, as it stands, has a charge. So think about that. Nothing has a charge. So if I go back here and I look at lithium, you already told me it has 3 protons. If there's no charge, how many electrons does it have to have? 3. So I know from that atomic number, it has 3 protons, 3 electrons. Does that make sense? Find gold. Tell me how many protons and electrons it has. First of all, tell me the chemical symbol for gold. Maddie? AU. And what is the atomic number of gold, Josh?
Wait, no. 79.
There you go, 79. So Carter, how many protons and electrons does it have? 79. So I would write 79p plus, 79e minus, if I were asked something like that. Here's my next question. How many neutrons? Anybody know how to figure that out? Okay, so we're going to learn. Let's start with lithium just because it's little. So lithium, you already told me that its atomic number was 3. So I'm going to ask you about its mass. It's called mass number. The mass number, first of all, we're going to say a couple of things about it. Look at lithium on your periodic table. Do you see that 6.941
Yeah.
underneath it? Okay, so mass number is the average, that's called the average atomic mass rounded to a whole number. So mass number is the average atomic mass rounded to a whole number. So if I come back up here and I put mass number, so I know my atomic number equals 3, my mass number equals the average atomic mass, which is that 6.941, rounded to a whole number. So if I take 6.941, Caleb, what's my whole number? 7. My mass number also equals the number of protons plus the number of neutrons. So I would say mass number equals P plus plus NO. That's how I would write that. Now I'm going to give you 2 minutes. I want you to get together with your lab partner and I want you to tell me how can you use this and what we've already learned to find the number of neutrons. Go. Figure it out. Don't talk about it till you get back there and then talk really quietly.
How do I find this method?
Oh man. Join the group behind you.
Alright.